Okay, so we are going to continue with parallel lines cut by a transversal, and we're going to bring in more of the algebra. So remember, how can we tell if the lines are parallel? Don't assume. Make sure you have little colored triangles on there. So bringing in the algebra piece, if this is 55 degrees and this is 3 w minus 2 degrees, you have to do a couple things. First, recognize the relationship, and then second, not just be able to name the name, but to also be able to identify, are they equal to each other? Are they equal to 180? What's the measurement relationship? So these, if we go back to one of our previous videos, with this shaded part being the interior, we have an angle on exterior and one on the interior. So this is not any of those that have consecutive interior or alternate interior, alternate exterior. This is the one that has one of each. So these are corresponding angles. And corresponding angles, if the lines are parallel, are congruent. So remember, if they are congruent, then I can set them equal to each other. So 3w minus 2 should equal 55. Solving, 3w equals 57, and w equals 19. So if we were to find out, or just be asked what was the variable, you would solve and get w equals 19. Okay, so let's label that as example 1. And let's move on to example 2. So again, we have a set of parallel lines, and we are cut by a transversal. And I know that they are parallel because we have the little colored triangles on there. Then we have 2x plus 9. And we have 111. And my little degree symbol's kind of thrown in there. Okay, so these are on the interior. So we only have two that it could be. We either have alternate interior or we have same side consecutive interior. Well, they are on the same side of the transversal, so that must mean that these are going to be consecutive interior. And we know that consecutive interior, when the lines are parallel, are supplementary. So that means that the 2x plus 9 plus the 111 should equal 180 degrees. So 2x plus 120 equals 180. 2x equals 60, therefore x equals 30. Let's check it and see if that works. If I put a 30 in here, I get 2 times 30 is 60, plus 9 is 69. So in other words, 111 plus the 69 better equal 180, and it does. One more question, one more example. Okay, so we have example 3. When we have more than one pair of parallel lines, you're just going to see a different number of triangles. So these have one triangle, so that means that those are parallel. These have two, so that means those are parallel. going to go ahead and extend this out. This is what my diagram has on it. And we're going to make this X and 110 degrees. And this is 1 and this is 2. So we are to find the measure of angles 1 and 2. Well, this angle and this one do not have any direct relationship because they are not sharing a transversal. Down the road, you will see this as a parallelogram. We are not there yet because that has some other special properties that goes with that. So we are going to focus on the idea of the parallel lines. What sometimes happens when you have diagrams like this, it would help to extend that line out or extend the side out and ignore the rest of it so that you are still looking at parallel lines cut by a transversal. So I know that this is 110. I could do this a couple different ways. I'm kind of lazy, I guess. So I'm going to go 110. So that means this is 110 because of alternate interior angles, which means that angle 1 and angle 110 degrees, these have to be supplementary because they are a linear pair. So that would make this 70 degrees. I could have gone the direct route with same side interior as well because those are supplementary. Just wanted to show you another option. Okay, so now, the measure of angle 1 is 70. For angle 2, what might be helpful, for whatever reason, sometimes it's helpful to turn your paper so that your parallel lines are like this. And same thing, I'm going to kind of extend this out so that I can just get a visual. So now I'm looking for the relationship of angle 1 and angle 2. Here's your parallel lines. So there's your parallel lines. And so you're looking at angle 1 of 70. And angle 1 and angle 2 have a relationship of same side interior again. So I know then that the measure of angle 2 has to equal 110. Another way of looking at this is that if you look at the angle that I found out here and this one, these would be congruent because they are corresponding. There's all kinds of ways that you could be looking at this kind of a diagram. But it is very helpful to extend these out and then to also turn your paper if you need to.